Alright, we're asked to simplify the radical. This statement here is important. It's important to include it. It doesn't actually concern you to any great extent, other than it keeps everything under this radical sign legitimate. That is to say, all variables represent positive numbers. If you end up with a negative value underneath the radical sign, there is no solution in the real numbers, so that would be a problem. In this case, even if m was negative, if you raise it to the fourth power, it won't end up being negative, so that wouldn't really be a problem. But the other thing that this statement takes care of, assume that all variables represent positive numbers, is the possibility of 0 in the denominator. Okay, 0 is not considered to be positive or negative. So if a number is positive, it is greater than 0, and that prevents the possibility of 0 ending up in the denominator, which would be undefined. Okay, so in order to simplify this, I'm going to rewrite what I'm given, because 125 is not a perfect square. So let's see if within 125 there's a factor that is a perfect square. You can just grab your 125 and start listing all the factors. This first one's kind of not even a possibility. 2 won't work. 3 and 5 is 8. 3 doesn't go into 125. 4 won't. 5 times 25 is a factor of 125, and 25 is a perfect square. So I'm going to rewrite 125 as 25 times 5. Okay. And I could just as well have written 5 times 25. I just tend to put my perfect squares as if they're almost out of the radical. And m to the fourth, well, I'm just going to leave that m to the fourth, because that's an even number exponent. So I can take the square root of this, and I think I'll work sideways since I have a rational expression. The square root of 25 is 5. The square root of m to the 4 is m squared. And you notice this the square root of m to the 4 is m squared. So the only thing left in here is a 5. Well, that's still under the radical. So your simplified form of this expression is 5 times the square root of 5 over m squared.